Hello everyone, welcome to eMaths. My name is David Apashki and I'm here to help you master mathematics and give you the edge you need to succeed in your exams. Here at eMaths Edge, I will practically be solving mathematics past question for senior school examinations. Here I will be breaking down the whole process into simple, easy to understand steps. I actually understand that preparing for math exams can really be hectic, but believe me, understanding how to approach these questions, most especially the essay parts, will ease you a whole lot of stress. And that is what this platform is designed to do for you. Each video is designed to boost your confidence and make math exam feel less like a mystery, but more like a basic thing you can conquer. So with that being said, let's get started. So in this video, we are going to dive into the topic matrices. And before we go into solving problems or answering past questions from the topic matrices, we need to go ahead and explain in details to try to understand what the general concept of matrices are. We need to understand what is a matrix. We need to understand some basic terminologies in matrices. And we also have to understand the operations that have to do with matrices for us to be able to tackle any questions that come from this topic. So, without further ado, let's begin. Let's bring out the objectives of this topic. The objectives. And what are those objectives? We have to first of all look at the definition. What is the term matrices or metrics? And we're also going to look at some basic terminologies in matrices. And lastly, we are going to look at some basic operations on matrices. Now, let's begin with definition. And first thing you need to note is that matrices is a plural form of the word metric. So, what is metric? A metric is a rectangular array of numbers symbols or expression enclosed in a square bracket. So a matrix is a rectangular array of numbers, symbols, or expression enclosed in a square bracket. So let's look at example. If you have anything in the form of this A, B, C, D, it's a matrix. Or if you have anything in the form of this 1, 2, 3, enclosed in a square bracket 4, 5, and 6. Or if you have anything in the form of theta and beta, right? Or if you have anything in the form of 2x, 3x, 4x, enclosed in a square bracket where we have 5x, 6x, and 7x. Mind you, A matrix is a rectangular array of numbers, symbols, or expressions. So this is an expression, these are symbols, these are numbers, and these are letter or alphabet. So whichever format you see a set of numbers or expression or even symbols enclosed in a square bracket, it is regarded to as a matrix. We have so many examples of matrices. So with time we are going to look at all those matrices and identify what type or what kind of matrix is this or that. So let's proceed. The next thing we are going to look at is terminologies. What are those terminologies in matrices? So these are basic words or basic terms which we need to take note of as regards to matrices. When you hear a row matrix or a column matrix or a transpose, you should be able to identify that what is this talking about. So we are going to look at those basic terms one after the other with examples in order to understand those terms or those words better. So the first one we are going to be looking at is the order of a matrix. Order of matrix. Now, what is the order of matrix? The order of a matrix is the size of a matrix determined by the rows and columns. So the order of matrix is the size of that matrix which is determined by either the row or the column or by the row and the column. So let's look at example. If you have such a matrix where you have A and also C, the enclosed in a bracket. Also remember that the array of numbers that ranges from left to right, which is in horizontal form, makes up the row, while the array of numbers that is arranged from top to bottom, which makes a vertical row or a vertical line, is known as the column, right? So having known that horizontal array of numbers makes up the row and vertical array of number makes up the column, it will now be easy for you to identify the sizes or the order of this matrix. So in this case, we can say that this matrix, let's name it or target matrix A. In this case now, we can say matrix A is a 2 by 2 matrix. Why? Because it has two rows, which is 1, 2, and it also have two columns, which is 1, 2. So in this case, we can say the order of this matrix is a 2 by 2 matrix, or we can have matrix B to be equal to 1, 2, 3, enclosed in a bracket 4, 5, and 6. Now, how many rows do we have? These are the rows. From left to right is the row, while from top to bottom is the column. So in this case, we have row 1, we also have row 2, right? How many columns do we have? We have column 1, which is C1. We also have column 2, tag as C2, and we have column 3, which we tag as C3. So in this case, how many rows do we have and how many columns do we have? We have two rows, which is row 1, 2, and we as well have three columns, which is column 1, 2, 3. So in this case, we can say that the order of this matrix B is a 2 by 3 matrix. So that about the order of a matrix. So what we are going to be looking at, or the next terminology we are going to be looking at, is elements of a matrix. Now, what is the elements of a matrix? So the elements of a matrix is the individual items in the matrix. Let's say we have a matrix A, B, C, and D. Let's say this is matrix D, right? So now, what are the elements of this matrix? This is matrix D. What are the elements? And we say the element of a matrix is the individual items in the matrix. So that is to say, the elements of this matrix now are, we have A, we have B, we have C, and D. These are the items or the individual items we have in this matrix, which is D. So D makes up the elements of the matrix. It can be alphabets, it can be numbers, it can be expression, and it can be symbols, just like we noted earlier about matrices. So the third items or the third terminology which we are going to be looking at is the row of a matrix or row matrix. Now, what is a row matrix? A row matrix is a matrix with only one row. Now, we know what a row is, right? From left to right, X, Y, and Z, enclosed in a square bracket. Now, this is a row matrix. Matrix A is a row matrix. Why? Because it has only one row. It has no column. For that reason, it is called a row matrix. It can be numbers 1, 2, 3, right? Or it can be expressions like 2x, 3x, 4x, right? And it can be symbols, it can be anything, but it must not have column. It must be only one row. So whenever you come across such type of matrices, just know that it is called a row matrix. So the fourth term we are going to be looking at is the column matrix. And what is a column matrix? A column matrix is a matrix with only with only one column, just like the row matrix, right? So matrix A, we can have it to be as 1, 2, 3. Is an array of number arranged from top to bottom, right? Or we can have it to be an expression 2x, 3x, enclosed in a bracket. It has only one column, it has no row. So the next term we are going to be looking at is the square matrix. Now, what is a square matrix? A square matrix is a matrix with the same number of rows and columns. So, e.g., we have AB enclosed CD. Now, this has a number of rows, row 1, row 2, right? And it also has two columns, column 1 and column 2. So this makes the order of this matrix to be 2 by 2 matrix, right? So in this case, since it has two rows and two columns, it is identified as a square matrix. Or in a situation whereby we have three rows, 1, 2, 3, we have 4, 5, 6, we have 7, 8, 9. Now we have row 1, we have row 2, and we as well have row 3. Here also we have column 1, we have column 2, and we also have column 3. So in this case, we have 3 rows and 3 columns. So the order of this matrix becomes 3 by 3 matrix. So since the number of rows and number of columns are the same, it is identified as a square matrix. It can be 2 by 2 matrix, it can be 3 by 3 matrix, and it can be 4 by 4 matrix and all that. So you must note that the number of rows must be equal to the number of columns for that matrix to be identified as a square matrix. So the next term we are going to be looking at is the diagonal matrix. And what is a diagonal matrix? A diagonal matrix is a square matrix where all elements is a square matrix where all elements outside the leading or the main diagonal are zeros. Let's look at examples. Let's say we have a matrix as this A 0 0. We have 0 B 0. We have 0 0 C. Now This is a 3 by 3 matrix, right? Now, if you observe the elements, mind you, a diagonal matrix is a square matrix, so it must be a square matrix, either 2 by 2 matrix, 3 by 3 matrix, or any other form that must have the same row and the same number of columns as well. So it's a square matrix where all elements outside the leading diagonal or the main diagonal, this is a diagonal line. The main diagonal have elements or alphabets like A, B, and C, while every other element outside the main diagonal is zeros. So whenever you see a matrix in this form, always note that it is a diagonal matrix. Here we have alphabet A, B, C. In other case, it might be numbers 1, 2, 3, or symbols or expressions. But the key thing to note is the element outside the main diagonal must be zero, or it can have 2x, 0, 3x, 0, 0, 4x, 0, 0, 0, 5x. Now, if you observe, the elements at the main diagonal are represented with expressions while every other element is zero. So this is a 3 by 3 matrix and this is a 4 by 4 matrix. Mind you, the first condition you need to identify a diagonal matrix with is it must be a square matrix. Then secondly, the elements outside the leading or the main diagonal must be zero. So whenever you have such kind of matrix, note that it is a diagonal matrix. So the next terminology we are going to be looking at is the identity matrix. Identity matrix. Now, what is identity matrix? An identity matrix is a diagonal matrix where all the diagonal elements are 1, right? Let's take an example where we have a 3 by 3 matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is a 3 by 3 matrix. Now look at this matrix closely. Let's target matrix A. When you look at this matrix closely, you will observe that all the diagonal elements are 1, but every other element are 0, 0, 0, 0. Or that makes this matrix an identity matrix. Why? Because all the diagonal elements are 1, but every other item or element in the matrix are 0. So anytime you see such kind of matrix, note that it is an identity matrix. So the next one we are going to be looking at is the zero matrix. Now, what is a zero matrix? A zero matrix is a matrix where all the elements are zeros. Now let's look at example. Let's say we have a 2 by 2 matrix 0 0 0. This is a 2 by 2 matrix, right? Or if we have a 3 by 3 matrix where you have all the elements to be zero. So such kind of matrix is called zero matrix. So the next terminology we are going to be looking at is the upper triangular matrix. This is a square matrix where all the elements below the diagonal are zeros. Upper triangular matrix. This is a square matrix where all the elements below the diagonal elements are zeros. Now let's look at example. Upper triangular matrix is a square matrix where all the elements below the diagonal are zero. So first thing you need to note is it must be a square matrix, either a 2 by 2 matrix or a 3 by 3 matrix or any form of square matrix. And the second thing you need to also note is that the diagonal element, the element below the diagonal must be zeros. So let's bring it out. Let's say we have A, B, C, right? Mind you, this is the diagonal. 0, D, E, 0, 0, F. Now, the first thing first, this is a square matrix. This is a 3 by 3 matrix with 3 rows and 3 columns, right? Also, remember that the elements below the diagonal must be zero. So where is the diagonal line here? We have these are the diagonal elements. We have A, D, F. Elements below the diagonal must be zeros. All these items must be zero. That is what makes this matrix an upper triangular matrix. The elements below the diagonals must be zeros. Mind you, it must be a square matrix. So this implies that this matrix is an upper triangular matrix. So the next term we are going to be looking at is the lower triangular matrix. This is a square matrix. This is a square matrix where all the elements above the diagonal. Mind you, for upper triangular matrix, we said all the elements below the diagonal must be zeros, right? So let's bring out the square matrix, e.g., such that we are going to have, let's say, 1, 0, 0. We have 2, 3, 0. We have 4, 5, and 6. Now, here is the diagonal. This is the diagonal. But every other element above the diagonal is 0. So that makes this matrix a lower triangular matrix because every other element below the main diagonal is a valid number, whereas every other element above the main diagonal is 0. So we can conclude that matrix A is a lower triangular matrix. So these are the basic things to take note of when it comes to the upper triangular matrix and also the lower triangular matrix. It forms an angle at the upper part of the matrix. That's for upper triangular matrix. And also for the lower triangular matrix, a triangle is formed at the lower part of the matrix. So the next terminology we are going to be looking at is the transpose matrix. Now, what is a transpose matrix? Transpose matrix is obtained by flipping the matrix over its diagonal. In other words, the row becomes the column and the columns becomes the row. Now let's look at example. Let's say we have a 2 by 3 matrix A, B, C, D, E, and F, right? Let's say this is matrix A. Now, based on the definition, transpose matrix is obtained by flipping the matrix over its diagonal. Now, in other words, the row becomes the column while the columns becomes the row. So this is the row A, B, and C. This is the first row, and this is the second row D, E, and F. While for the column, we have the first column to be A and D, which is C1, B and E, which is C2, and C and F.
which is column 3, right? But in this case, since the row becomes the column and the column becomes the row, this implies that the transpose of matrix A, which is A to the power of t, is going to be, now, since we have the row to be A, B, C, that means the first column is going to be A, B, C. And for the second row, we are going to have it as the second column, which is D, E, and F. So, in other words, you will observe that a 2 by 3 matrix becomes a 3 by 2 matrix. So that is that about transpose. It's all about flipping the matrix over the diagonal. In other words, the row becomes the column and the columns becomes the row. The first row becomes the first column and the second row becomes the second column. Also, let's look at example 2 for better understanding. Now, let's say we have matrix P to be a 3 by 3 matrix with the following elements. We have 2, 1, 2, 2, 2, 3, right? And the second row we have 3, 1, 3, 2, 3, 3. While the third row we have 4, 1, 4, 2, and 4, 3. Now, if you are to obtain the transpose of this matrix P, the first row will become the first column. The second row will become the second column, right? And the third row will become the third column. So let's go ahead and do that. B transpose is now going to be, now what do we have as the first row? We have 21, 22, and 23. So it means we are going to have the first row to now be the first column. So we are going to have it as this 2, 1, 2, 2, and 2, 3. First column is obtained from the first row of the initial matrix B. Second column, the second row is now going to be the second column, which we have to be 31, 32, and 33. We are now going to have it to be the second column. So it's going to be 31, 32, and 33. Now for the third row, we have 41, 42, and 43, which we are going to have to be the third column, which is 41, 42, and 43, all enclosed in a square bracket. So that is that about the transpose of a matrix. So the next thing, or the next terminology we are going to be looking at, is the determinant of a matrix. Determinant of a matrix. Now, what is the determinant of a matrix? The determinant of a matrix is a single value or a scalar value that is obtained or computed from a square matrix. Now, determinant of a matrix is a single value or a scalar value that is obtained or computed from a square matrix. That's to say, the first requirement must be that it is a square matrix. So let's look at example. Let's say we have matrix A to be equal to A, B, C, and D, a 2 by 2 matrix, right? So if we are to obtain the determinant of this matrix, it means we are to compute for a single value or a scalar value for this matrix. So what we are going to do is simple. To obtain the determinant of this matrix, we are going to have determinant A to be equal to, now the diagonal of this matrix, the main diagonal is A down to point D, right? A and D forms the diagonal of this matrix. It is going to be the product of the main diagonal, the product of the elements that makes up the main diagonal minus the other diagonal, which is C and B. So let's have it to be A multiplied by D, which forms the main diagonal A and D, minus C multiplied by B, which forms the other diagonal that is perpendicular to the main diagonal. So by such doing, we are going to have our single scalar value. Now let's take an example with numbers so that it will become clearer. Let's say we have matrix A to be 4, 2, 3, 1. Or let's say 3, 4, enclosed in a bracket. So the determinant of A is going to be the product of the diagonal elements, which is going to be 4 multiplied by 4 minus the product of the other diagonal, which is 3 multiplied by 2, right? So 4 multiplied by 4, we are going to have 16, minus 3 multiplied by 2, we are going to have 6. 16 minus 6 is going to give us 10, which gives us a single value or a scalar value, which we consider to be the determinant of this matrix A, which have elements 4, 2, 3, and 4. So that is that about the determinant of a matrix for 2 by 2 matrix. So let's further go ahead and obtain the determinant of a 3 by 3 matrix as well. So now we are going to look at the determinant of a matrix with a 3 by 3 size. So now we are going to look at a 3 by 3 matrix, how to obtain the determinant of a 3 by 3 matrix. So here we have a 3 by 3 matrix which we named to be B, which has the elements A, B, C, D, E, and F, G, H, and I. So let's go ahead and see how to obtain the determinant. So for you to be able to successfully obtain the determinant, which is a single value or a scalar value, which we defined it to be, what you are going to do is, now we have 3 rows and we have 3 columns. Unlike the 2 by 2 matrix where you multiply the major diagonal minus the other diagonal. So in this case, what you will do is you will pick the first element, which is in the first row and first column. So let's have it here. We have A, Since we pick the first element, which is in the first row and the first column, that's to say we will consider the first row and also the first column void, right? So we are going to focus on E, F, H, and I. So now for us to consider the first row and the first column void, we are going to have this to be E, F, H, and I, right? So also we are done with the first element. Going to the second element, which is in the first row and second column. So if we are picking the second element, we are going to consider this void, that's this first row void, and also the second column. So we are going to focus on D, F, G, and I, right? So we are going to have it to be, but mind you, picking the second element is going to be a negative into, we are going to have D, F, G, and I, plus the third element, which is C. So now, since we are picking the third element, which is in the first row and the first row and the third column, so that's to say we are going to focus on these other elements D, E, G, and H. So we are going to have it to be C into, we're going to have D, E, G, and H. So with this, we can say that the determinant of B is equal to, we have A into the bracket of E multiplied by I. We are going to have EI minus F multiplied by H, which is this, multiplying this, and we have this multiplying this. So we are going to have it to be FH, right? Minus B into the bracket of the main diagonal, which is D and I. We are going to have it as DI minus the other diagonal, which is G and F. We are going to have it as FG plus C into the bracket of the main diagonal, which is DH, minus the other diagonal, which is EG. So it from this point, it will now be very easy to simplify if we have all this as single numbers. It will be easy for us to add or subtract where necessary. So that is the approach for a 3 by 3 matrix. So let's go ahead and substitute numbers into this alphabet so that we can get a single value, because we define determinants as a single value or a scalar value computed from a square matrix. So let's use real value to see if we can obtain that single value or a scalar value which we are looking for. Let's say an exercise. Let's say if B happens to be a 3 by 3 matrix which contains the elements 1, 2, 3, 4, 5, and 6, 7, 8, and 9, right? Find the determinants. So now we are going to use the same approach which we use for the above example. So let's go ahead and use it to see if we can obtain a single scalar value from this. So since we have matrix B to contain the elements 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's go ahead and use the same approach solution. So we are going to have this to be the determinant of B is going to be, now what is the first element? The first element in this matrix is 1, right? So we are going to have 1 into, so since we pick the first element to be 1, it means we are going to consider the first row and the first column to be void, where we are going to have 5, 6, 8, and 9 to deal with, right? The second element, which is minus 2, if we pick minus 2, which is in the first row and second column, we are going to focus on 4, 6, 7, and 9. So we are going to have it to be minus 2, 4, 6, 7, and 9. And plus the third element, which is 3. So if we pick 3, which happens to be in the first row and third column, it means we are going to focus on 4, 5, 7, and 8. So we are going to have it to be 3 into 4, 5, 7, and 8. So with this, it will now be easy for us to simplify such that we are going to have 1 multiplying 5 multiplied by 9. We are going to have it to be 45. 45 minus 8 multiplying 6. We are going to have it to be 48. Close the bracket, minus 2 into 4 multiplied by 9. We are going to have it to be 36 minus 7 multiplying 6, we are going to have it to be 42. Close the bracket, plus 3. 4 multiplying 8, we are going to have it to be 32 minus 7 multiplying 5, we are going to have 35. Close the bracket. So with this, we are going to have 1 into the bracket of 45 minus 48 is minus 3, minus 2 into the bracket of 36 minus 42 is going to give us minus 6 plus 3. 32 minus 35 is going to give us minus 2. Minus 3. So with this, we are going to have 1 multiplied by minus 3 to be minus 3. Minus 2 multiplied by minus 6 is going to be positive. Why? Because minus multiplying minus is going to be positive, and 2 multiplying 6 will give us 12. And the last one, plus 3 multiplying minus 3 is going to be minus 9, right? So with this, we are going to have, we have two negative numbers here, which is minus 3 and minus 9, which if you sum up is going to give minus 12 plus 12. So we have the scalar value or the single value to be 0. So 0 is the determinant of the matrix B, which contains this element 1, 2, 3, down to 9. So that is how to obtain the single value or the determinant of a matrix with a 3 by 3 size. So that will be all for this video. Stay tuned and engaged for the next one. Also remember that the goal of this platform is to solve as many past questions as possible just to help you overcome what I call maths exam tension. So if you have any challenging question from this topic, you can as well drop them at the comment section or reach out to me via email or DM and I will be glad to assist. Thanks for watching and have a great day.